Assalamu alaikum, bachcho. So today the topic that we'll be covering is vectors. First, let's just understand some basic things regarding vectors and then we can start. There are four ways to represent a vector. So here, four notations to write down a vector. One is the column vector. We have done three of them in O-level mathematics as well. And the fourth one might be new for few people. One is writing them as a column matrix or a column vector in which the topmost is the movement in X, and then it's the movement in Y, and then it's the movement in X. The same column matrix or column vector can be written in Cartesian form. In this way, xi plus yj plus zk. Again, where x, y, and z are still the movements of x, y, and z axis respectively. And I, j, and k are unit vectors in each respective directions. So if I want to tell someone that I have moved 3 units in the x-axis, I'll write it as 3i. I is a unit vector, the magnitude of which is 1. We'll be doing it in detail as well. Third way of writing down any vector is you mention the 2 points and you put an arrow on top. That's a vector from A to B. And the fourth is representing a vector through a small bold alphabet through which you can label or name any particular vector. Is this clear? 4 ways of writing down a vector. Okay, then comes addition and subtraction of vectors. I strongly urge everyone to avoid subtracting vectors. Do not go for vector subtraction. Always go for vector addition, because in vector addition, it's logical, it's conceptual, and you can add as many vectors as you want. On the other hand, subtraction is mostly limited to 2 vectors. So never, till date, during my entire life, I've never initiated the subtraction of vectors. If they are to subtract themselves, let them be. But we aim on adding vectors. If I want to go from A to B, I start from A and I go till O, and then plus from O till B. Similarly, if I want to go from A till D, I'll go from A till O, then O till B, then B till C, and then C till D. In addition, the main logic is where you end on a respective vector, the second vector should start from the same point. Is this clear? In particular, any general vector is also called displacement vector. Any vector, vector A, B, vector AD, all of these are called displacement vectors. Okay, now what is a position vector? We have also done this in O levels, but in 2D, in A levels, we'll do it in 3D. A is a point 2, 1, and minus 5. Now I can write the vector of A from the origin, which will be called the position vector of A. And in this case, I'm calling it OA, and that can be written as 2i plus j and minus 5k. Is this clear, class? Is this clear?
Yes, sir.
Okay. Next, we move on to the magnitude of a vector. You have also done this in O-level mathematics, but in 2 dimensions. In 3D, we are still using the Pythagoras theorem, but now we are using the Pythagoras theorem twice. So eventually we end up getting under root of x square plus y square plus z square, which is the actual magnitude or the length of a vector. Is this clear, class?
Yes, sir.
Now understand a unit vector. If I make a, I'm trying to explain it in 2D so that it is easier to understand, and then we'll go into the 3D model as well. If I have a vector 4, 3, you know the movement in X is 4 and the movement in Y is 3. If I want to make a vector, this is the direction of that particular vector, in which you can see that the movement in X is 4 and the movement in Y is 3. Now, what is the magnitude of this vector? Can you find the magnitude of this vector? Yes. If the movement in X is 4 and if the movement in Y is 3, what is the magnitude of this vector? 5. Absolutely right. The magnitude is 5. Now, if I make 5, okay, if I were to get a vector in the same direction, but with a magnitude 10, what will that vector be? Same direction, but with a magnitude 10. What will that vector be? You double the entire vector, you get 8 and 6. Now, if I want to get a vector in the same direction, but with magnitude 2.5, then what? 2 and 1.5. So now if I want to get a vector in the same direction, but with magnitude 1, 4/5 and 3/5. So technically you are taking the vector and you're dividing it by its magnitude to get a unit vector. A unit vector can be in any particular direction, but it always has a magnitude of 1. Is this clear, class?
Yes, sir.
These are the 3 kinds of vectors we need to understand before we go on understanding the vector equation of a line. What is a unit vector? Yes, class. We just discussed it. What is a unit vector? What is a unit vector? A vector that has a magnitude of 1, right? What is a position vector? The vector of any point from the origin. What is a displacement vector? Any vector can be a displacement or a direction vector. Displacement vector can also be called a direction vector. Any vector from A till B, B till C, A to D, these are displacement or direction vectors. If you're talking for any particular line, these are direction vectors as well. Is this clear, class? Okay, now understand the vector equation of a line. There are 2 things that students confuse themselves with. Remember, this is the equation of a line. What does an equation of a line give you? You have studied equations of lines in AS and O levels as well. What does it give you? It gives you different points on the line, right? It gives you the relationship between different points that exist on the line, right? It provides you with the coordinates. Now we'll be making the same equation using vectors. Is this clear, class? We'll be making the same equation using vectors. Okay, first, understand something. I'll be making a vector. Okay, class. Now this is a vector. First, understand the things that I'm providing you with. I've given you the coordinates of A. This is provided. And I've given you the coordinates of B. This is also provided. Now I want you to find the coordinates of M using vectors. How do you do that? Yes, class? How do you do that? If I've given you the coordinates of A and if I've given you the coordinates of B, how do you find the coordinates of M using vectors? Yes?
Sir, midpoint.
No, I don't want to do it via coordinate geometry. I want to do it using vectors. No, 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 no. I'm saying I want to do it using vectors. Okay, can I do this? Kindly draw this to understand the entire concept. I need the coordinates of M, right? The O is the origin, right? O is not mentioned in the figure. It is somewhere because we will be dealing in 3D spaces, so we will not be able to identify where O is. So O is the origin. We just discussed that the coordinates of any points can also be written as the position vector of that particular point. So once I told you to find the coordinates of M, the first thing you should have jumped on is that we need to find OM. And OM can be found by taking OA plus AM, right? In place of AM, can I just write half of AB? Is this clear?
Yes, sir.
Is this clear, class?
Yes, sir. Yes.
What about the rest? I'm just hearing one yes, sir.
Yes, sir.
Okay, now what if I tell you that N is a midpoint of AM? Now, if I want you to find the coordinates of N, can I do it this way? ON is OA plus AN, and in place of AN, I can write just a quarter of AB. Agree?
Sir.
Sorry, Taha, any question?
Yes, sir. Yes, sir.
Now, if I tell you C is a point which is an extension of AB, and now B is the midpoint of AC. B is the midpoint of AC. Now, to get the coordinates of AC, can you do this? Can you say that OC is basically equal to OA plus 2 times OB or 2 times AB? Is this clear, class? What do you observe in all these things? What do you observe? The three highlighted equations that we are dealing with, what do you observe? Everything is almost the same. Only two things are changing. If I change the point, just one other thing changes. What is that? If I change the point, if I wanted M, I got a half over here. If I wanted N, I got a quarter over here. Yes, the scalar multiple of AB is what is changing, nothing else. So with every changing point, your scalar multiple of AB is changing. The rest of the two always remain the same. Is this clear, class? Class, is this clear?
Yes, sir.
Okay. So now concluding this entire thing, I can say that if I wanted to find any point on the line, which I am calling X, the position vector of any point on the line X, OX, can be written as OA plus T times AB. I just don't know the value of T because I don't know where the point X is. Can I do that? I just put in the appropriate values of T and I get to the point X. Agreed? So the conclusion of all these is this. Now, if X is on the other side, I'll get a negative value of T. That is not a big deal, but it remains a scalar multiple. Is this clear, class? Is this clear?
Yes, sir.
So now summarizing this, we come to the equation, vector equation of a line, which is written in this form. Remember, R, A, and B are vectors. What is R? It is the position vector of any point on the line. Just like in a straight line equation, we have y and x, which can be any points on the line. So similarly, R is the position vector of any point on the line. A is the position vector of a known point on the line. Like in the previous examples, we were using OA, OA, and OA. If anyone wanted to use OB, yes, they could have used that as well. But A is the position vector of known point on the line. And B is the direction vector of the line. And T is a scalar multiple which changes with the point R. Is this clear, class?
Yes, sir.
R is equal to A plus TB. Okay, there are three relationships. Is this clear? Vector equation of a line. We'll try to cover the entire concept of vectors today, and then we'll move on to the questions. Is everything clear till this point? Any question?
Yes, sir. Yeah.
R is equals to A plus TB. Please understand here, R is a point that can be anywhere on the line, and T is a scalar value that changes with the point. It can be positive, it can be negative, it can be in a fraction, it can be an integer, it can be anything. But it is the value that changes with every point. A can be any known position vector. In the last example, I took it as OA. You could have taken as O. You could have also just taken it as OB. Nothing would have changed. And B is the direction vector of the line. Okay, now there are three relationships that can exist between a lines in 3D. I'll help you understand and imagine it. The two lines either intersect. It's also easy to understand in 2 dimensions as well. If they intersect, that means they must have a common position vector. Agreed or not? The point where they are intersecting, that must be a position vector of both the lines, right? If they are parallel, their ratio of x, y, z of the direction vector remains the same. And the third condition is that the lines are skew. Now, what are skew lines? Let's try to understand this. They are neither parallel nor do they intersect. Now, everyone is, wherever you are sitting, there must be a floor there, right? Now, imagine it in 3D. Make a diagonal on your floor. Imagine a diagonal on the floor on which you're sitting. Imagine a diagonal on that floor, right? Imagine a diagonal on that floor. Imagine a diagonal on that floor. Now imagine a line on the roof which is not a diagonal. Any line on the roof which is not a diagonal. Now these two lines, are they parallel? Will they ever intersect? But they are skew. Now understand one thing. Now, if I'm calling them skew lines, what did I just tell you? Imagine a line on the roof, which is not a diagonal, and a diagonal on the floor. Now consider that I have a pole in my hand, and I ask you to place that pole at such a point that its top and bottom touches the two lines that you have imagined. Can you do that? Can you do that? There must be a point where top maybe you have the same line, and the floor's line also passes from that point, and you place a pole there which touches the line that you've imagined on the roof and the line that you imagined on the floor. Now I can say that just the z coordinate of that point is different. The x and y coordinates of those points are the same. Agreed or not? only their z coordinate is different. So for skew lines, there are points where two of the coordinates are the same, but the third one will not be the same. Is this concept clear, class? So whenever we
Yes,
want to prove that the lines are skew, we always look for a point of intersection, and that point of intersection will never be satisfied by all three coordinates. Is this clear? Is the approach clear? Now let's go through the scalar multiplication. Then we'll be done. Okay, now scalar product or dot product between two vectors. Scalar product and dot products between two vectors. Now, two vectors can actually multiply and give you a scalar. Science students would better understand that because they take force and displacement and they multiply it and they get energy. Force and displacement are two vectors. When they multiply the two vectors, they get energy, which is a scalar. So there are conditions where the two scalars multiply and they give you, the two vectors multiply and they give you a scalar. And the dot product is taken as the magnitude of the two vectors and cos theta, where theta is the angle between the two vectors. Notice one thing, if I know that I want to find the angle at point B, if there are two vectors and I want to find the angle at point B, I'll say I'll take the vector AB and I'll dot product it with the vector CB. Reason? We either take the two vectors approaching the point or the two vectors going away from the point. If I were to find an angle at any particular point, agar kisi point pe nahi nikalna, phir that's not a big deal. That's nothing to get confused about. If I want to find the angle at any particular point, I must make sure that I take the two vectors either approaching the point or going away from the point. अगर मैं B पे निकालना चाह रहा हूँ, if I'm taking AB, A is approaching the point B. So the other vector I'll take is CB. तो मुझे ABC का जो B का angle है वो actual angle मिलेगा. If points नहीं है, the question says find the two vectors, the angle between the two vectors, फिर तो कोई मसला नहीं. Is this clear, class? Okay. Similarly, if I take the vector Ni and I dot product it with the vector I, दोनों का magnitude 1 and 1 and they are unit vectors, both in x direction, right? And cos of what is the angle between the two vectors? दो vectors I हैं, अगर दोनों x direction में unit vectors हैं, what is the angle between them? दो vectors हैं I and I.
90.
90? How 90? Two vectors both in I direction. How do I get it as 90? 0 degrees or 180 degrees अगर opposite होते तो okay, let's take it as 0, which is absolutely right. The same direction है तो they are 0. Cos of 0 is 1. So one thing is for sure that sir I or I का dot product will always be 1. Similarly, J and J dot product will also be 1 and K and K dot product will also be. I is a unit vector in the x direction. Unit vector in the x direction. Unit vector का तो magnitude ही 1 है. ठीक है ना? I'll explain. I dot J. Both the magnitudes are 1. Now, what is the angle between a vector that is in the x direction and the vector that is in the y direction? What is the angle between them? The vector between an x direction and the vector between a y direction.
90.
90. So cos of 90 is what? 0. Cos of 90 is 0. So I dot J is 0. Similarly, I dot K will also be 0. And similarly, J dot K will also be 0. Sorry? Degrees. Obviously, I'm telling you 90 degrees. They are perpendicular technically, right? Any vector in x, y, and z direction are perpendicular to each other. Look at your floor, the two walls, right? All of them are perpendicular to each other. So if I give you these two vectors, A, B, and C, B, and I tell you to find their dot product, what will you do? Simply you just multiply them just like you multiply every other bracket. But what happens, 4i will multiply with I, and I or I ka dot product will be 1. So I can just directly multiply their coefficients. Can I do that? सिर्फ दोनों coefficients multiply करता हूँ, 4 into 1, which is 4. Okay, now I take 4i and I multiply it by minus j. But I know I और j का dot product क्या हो जाएगा? What will be the dot product of I and j? 0. So no need to multiply. Similarly, I को k से भी multiply करने की जरूरत नहीं है, because you get it as 0. Then you take 2j and you multiply it with all of them. I के साथ dot product 0 and j के साथ you get the dot product which is -2 and k के साथ भी 0. तो हमने एक shortcut बना लिया. We made a very easy pattern out of this. Just multiply their coefficients. x को x के साथ multiply करो, y को y के साथ और z को z के साथ और सबको plus करो. Is this clear? So that saves time, but technically इसके पीछे लग dot product ही रहा है. Is this clear, class?
जी सर.
Anything that is not clear till this point?
No sir.
Scalar product, vector equation of a line, simple vectors. Is this clear, class?